Saxon's Trig, lesson 36, about angles greater than 360 degrees, sums of trigonometric functions, and then boat in the river problems begins on page 256. So part A is exactly as it sounds, angles that are greater than 360 degrees. How do we graph those? So if we just do an example of, let's keep it simple, 370 degrees, and they want me to graph that. If I start at 0 and I go all the way around, I've used up 360 degrees, but I still have more than that to go. So I've got a little bit more of a sliver, which puts me into quadrant 1, and that's where I'm going to draw my triangle. And how much more past the 360 did we move to get to 370? 10 degrees. So 10 degrees would be in that gap. So that is the basic of what they're giving you with angle or with section A. So we can have, if you go one time around, if you're more than 360 degrees, if you go 2 times around, that's more than 720 degrees, and so on as it keeps getting bigger. So there in part B, they remind you that we can add trig answers together, and we can have numbers that are either less than or more than the 360. So in example 1, they give us cosine of 135 degrees plus tangent of 330 degrees. So none of these are the greater than 360 that we were just talking about, but we're going to graph each one. And 135 degrees starting at 0, going past 90, but I don't reach 180, so my triangle is formed in quadrant 2. How much shy of the 180 degrees is this 135? So it's 45 degrees. This part is the 135. So memorized 45 degrees gives me legs of 1. This one has to be negative because of quadrant 2, and the hypotenuse will be radical 2. Now it wants cosine, ca, adjacent over hypotenuse. So the adjacent here is -1, the hypotenuse is root 2, and we're adding that to this answer. So now we work on this one. 0, 90, 180, 270, 360. I didn't quite reach the 360, so the triangle is here. This uses up 330, so in the gap we have 30 more to make 360. Opposite the 30 is a 1. Adjacent will be the root 3 because this is 60 degrees, and opposite 60 is square root of 3. And this sign is positive, this sign is negative, and the memorized hypotenuse is 2. So tangent wants TOA, opposite over adjacent. The opposite is -1. The adjacent is root 3. So that's what we're adding over here is -1 over root 3. Now I chose to put a parenthesis around it because it was negative and I don't want to lose that fact. But to put together the two negative fractions, we have to have a common denominator, but I don't want to do a common denominator with these roots. So let's fix the root problem and then do the common denominator. So this one multiplies by root 2 over root 2. So we have negative root 2 over 2 when we simplify it, plus the negative, or I could have just said minus, either way, root 3 over root 3 gives me root 3 in the top, 3 in the bottom. Now my common denominator is easy to see, it's 6. So when I multiply this one by 3, I get -3 here. This one turns to 6 by multiplying by 2, so this is going to make it -2 here. So -3 root 2 minus 2 root 3 all over 6 is the, just double checking it, yep, is the answer they are looking for. Example 2 says to evaluate the cosine of -60 degrees plus cosine of 210 degrees. So we're going to graph -60. That's going to start here at 0 and go backwards because of the negative. And this would be -90, so I didn't even make it out of quadrant 4. So this is 60. Opposite the 60, root 3. Adjacent to the 60 is 1, or opposite the 30. Hypotenuse is 2. Make sure you put the signs. This one is negative, that one is positive. Cosine is ca, adjacent over hypotenuse. The adjacent is 1, the hypotenuse is 2, plus, and now we'll work on this answer, cosine of 210. 0, 90, 180, 270. I didn't quite reach 270, so my triangle is going to be in quadrant 3. This has used up 210, so how much past the 180 did I travel? 30. Opposite the 30 is 1. This would be 60, so this would be radical 3, hypotenuse of 2. This is negative. This is also negative. It's looking for cosine. Again, ca, adjacent over hypotenuse. The adjacent is negative root 3 over the hypotenuse of 2. This has the same common denominator, so I don't need to make an adjustment. So it'll be 1 minus root 3 all over 2. Oh, let me flip the page to check that answer. 1 minus, yes, we are good. Example 3. They asked for cosine of 570 degrees plus sine of negative 765 degrees. These are both more than the 360, so we will have to do an adjustment as I do the graph. So if I start at 0, 90, 180, 270, 360, I still need to keep going. So let's do 570 minus the 360 of rotating around one time, and that's 210. Okay, so I don't need to wrap fully another time. I'm just going to go back to 0, 90, 180, didn't reach 270. So I'm past the 180 by how much? 30. Opposite the 30 is 1. Adjacent will be the root 3. They're both negatives. Hypotenuse will be 2. Yeah, I was just double checking that 30 degrees for a split second. I thought I was wrong. And cosine is ca, adjacent over hypotenuse. The adjacent is negative root 3 over the hypotenuse of 2. Let's write this down here because we're going to need it here to do the plus. Okay, now let's work on our negative. 765, 0. 90, 180, 270, 360. Okay, I've definitely gone around one time. So let's take that 360 off. So 405. So again, I know that that's more than 360. So I've wrapped a whole again. So that's another. So the total would have been 720. So if I had recognized that I had wrapped fully, I could have just minus the 720 and gotten straight to the answer I needed. But either way, you're going to get there. All right, so this is 45. So we've gone negatively twice, and then another 45 degrees will end in quadrant 4. 45, 1, 1, root 2 for memorized, positive, negative, and it wants sine. So sine is opposite over hypotenuse. The opposite is negative 1 over the hypotenuse of root 2. All right, now we need to simplify. Need a common denominator, but I need to fix this one first. So negative root 3 over 2 minus, and I've multiplied by root 2 over root 2, so that gives me root 2 over 2. Now I see they have a common denominator. I can just put them together, negative root 3 minus root 2 all over 2. Yes, that matches what the book has. So there is example 3. Now, section C is definitely a complete change in gear, and it is boat in the river problems. And this works for like airplane in the sky, anything where you have either a wind or a water or a something that is helping you move along. So you've got the speed of a boat or the speed of an airplane, plus it's being adjusted by the water or the wind that's affecting it. Okay, so that is dealing with the rate of how fast it's going. So these rates will be the boat plus the water helping it, or it will be the boat minus the water fighting it. So the words here will be downstream. So when I'm going downstream, the water's helping me. When I'm going upstream, I'm fighting the water, so the water will be minusing. So these will be the rates that I will use. And the rest of the problem is as you're used to seeing it. Rate times time equals distance. Now that you understand those basics, example 4. One day, Selby found that her plane, so again, they identify it as boat in the river, and then their example is an airplane, found that her plane could fly at 5 times the speed of the wind. Okay, so her plane can go 5 times the wind. She flew 396 miles downwind. So now I'm going to use this formula. Distance is 396. She flew 396 miles downwind. So downwind is going to use the rate. Okay, let's change this to P. Plane plus the wind, okay, and then the unknown time. And I'll fill in there in a second. Okay, 396 miles downwind in a half an hour more. Okay, so I know that this time here is a half hour more than something else it's talking about. Then it took her to fly 132 miles upwind. All right, so this one becomes relatively complicated. So this T in here is actually going to be this parenthesis with this half hour added to it, because if flying the other part took 3 hours, then this one should take 3.5 is what that was telling you. And then it implied the other equation, which was the plane minus the wind for a straight up T for time, but that distance was 132 upwind. So now I've done the upwind equation. What is the speed of her plane in still air, and what is the speed of the wind? Okay, so we have our two equations now, and I'm going to fix this when I rewrite it. But I also know that the plane is going 5 times the wind. So everywhere I wrote a P, I'm going to fill in a 5W. Okay, so we have 5W plus the wind, and this was an extra half an hour for time equal the 396. This one is the 5 wind minus the wind, plane T, and the 132. So I need to do a lot of fixing here in this messier one and a little bit here in this one. 5W plus W is 6W. Multiplying with T plus a half equals the 396. 5W minus W, 4W with the T equals 132. I know that I need to distribute up here, so 6W times T is a 6WT, and 6 times a half is going to be 3W equals the 396. Now, I have a WT weird combination here, but I also have it here. I can solve for this WT by dividing out by 4. So WT equals 33? Is that right? Yes. Okay, so now I have that, and I can plug it in, substitute 33 for WT instead of here. So we're going to have 6 times 33 plus 3W equals 396. As I continue to solve, you can see that we're solving for the wind. 6 times 33, 198, I hope, equals 396 minus 198. That's harder to do in my head. Let me check these numbers. 198, yes, 396. Okay, so wind is 60 miles per, no, wait a minute. They took it straight to the 66. So that has to be, oh goodness, 130 something, I think. Oh, foo. 396 minus 198, so 8, borrow again, should be a 9, okay, 198 divided by 3, this doesn't feel like it's working out right, divided by 3 goes in here 6 times, that's 18, oh yes it is, okay, so the wind is 66. And that's what I said from before. So the wind is 66 miles per hour. That's one of them. It also wanted me to find the plane. The plane is 5 times that amount, so that is 330. So the plane is 330 miles per hour, and that's the two things that it wanted answered.